Hello, welcome to Unit 2, Lesson 5, and we're looking at question number 24 in the projectile motion. So a pitcher throws a baseball at 140 kilometers an hour. First thing I want to do, I want to get that into meters per second because our formulas only work if we are working in the meters per second. So 140 divided by 6. So the pitch was launched at let's call it 3.9 meters per second. Plate is 28.3 meters away. So if we give ourselves a little bit of a diagram to help visualize, very accurate diagram. So here's the ball being thrown. Here's home plate. All right, so that distance, the 28.3, that is horizontal distance. So right away I'm going to set up my T-chart and separate my information into horizontal and vertical. So I know that delta D in the horizontal is 28.3 meters to the right. How far does the ball drop? So we want to know, this is the release point, how far does it drop when it gets to the plate? So we're assuming the ball started traveling horizontally. So the pitcher launched this ball horizontally, which means that that velocity that we calculated is actually v horizontal. So it was launched at 38.9 meters per second to the right. Horizontal is uniform motion for us in grade 11. So because it's uniform motion, that means it's only one formula for this particular column, and it's d equals vt. That's the only formula that works for horizontal. So that means the missing variable, is time, not d. And guess what? Because we know 1, 2 pieces of information, we can find our third. So we can find out how long did the ball take to get to the plate. So let's start with that. So delta D equals VT, 28.3 equals 38.9T. So this pitch, if you're standing in the batter's box, 38.9, it took 28.3 divided by 38.9. So it took about 0.73 seconds. So not very much reaction time there. So that's information I've calculated. Now, this does not help me at all vertically. I shouldn't say that. At this point, we have no vertical information except time. Time can go into both columns. It's interchangeable. It is the only variable that can appear in both columns and mean the same thing. So in the vertical, the same amount of time passed, 0.737 seconds. Now we have to read into this question. There's some information that's provided, but they just don't come out and say it. Because it started toward the plate horizontally, that means that there was no vertical motion at all at the point of launch. So that tells me that my V1 is 0 meters per second. And I'll say down, not that it matters. So now I have 2 pieces of information. I need 3 because I am looking for delta D. That's my unknown here. This is what the question wants. How far did our ball drop on its way to the plate? So there must be one other piece of information, and you can't forget about the one that is constant for us on Earth, 9.81 meters per second squared down. Now I have my 3 pieces of information. I need to pick a formula that will use those 3 and give me D. Fortunately, this one will work. Plus 1/2 AT squared. Substituting in my information, 0T plus 1/2 9.81, and we figured out the time it took to get to the plate. Don't forget your squared. 0T goes to 0. I just have to punch this into the calculator. 9.81 times 0.73 squared, and I get 2.6 meters. 2.6 meters it dropped. And it doesn't tell us the original height. So all we need to know is from the launch point to where it comes across the plate, it's dropped. Therefore, it dropped 2.6 meters. All right. There we go. That is the baseball question. All right. If you have any further questions or you need something clarified, let me know, and I'll do my best to further explain it.